another one. So if I go down, what do I have? I have 4. 4. And then I have a decision for what? For 5. So what was our action? We said if we get a 1, we want to drive motor A at what? Motor D should what? Be off.
A at a speed of 30.
And then motor A should be on at a speed of what?
30.
30. If we have a 2, what is the decision? Both motors should be what? On, but motor D should slow at what? 10. We chose 10, eh? 10. I follow you. So this time you are not stopping completely. You are only slowing down one wheel. And when you slow down, it gives you what? A 10. I follow you. And then if you have any value towards 3, it shows you are almost directly on course. So we said we would drive both motors at what?
30.
At 30. If we had a 4, what was our decision?
Both motors will be 1, but D will be 30.
G rather goes to what?
30.
30. And A goes to what?
10.
10. And then for this, what happens?
D will be on at 30.
D goes to 30.
And then A will be off.
A goes what? Off. So you can see how you can even have about 20 controls. And the more controls you have, the smoother you get to control what? It's like a car. A car with 5 gears compared to a car with just 2 gears. You are either speeding or you are slowing. I follow you. Assuming that was how our cars work. So we are done with this second decision or this second program. I can switch it to the tab mode by clicking on that, and I'm going to put the whole thing in a loop.
Please, does it mean that each tire will be able to attain a speed of 30, maximum speed of 30?
No, you can go as far as 100.
Per our program?
Yeah, per our program, yes, per our program. So what you are doing is, you have to, this is a training, but if let's say you are going for a competition, you will have to try, your speed and control balance is what gives you performance. So you have to now come up with what speed, with what control is best for me to navigate the town without skidding off or without losing track. So after the speed and control balance is practice, but the principle stays the same. So we put the whole thing in a loop. We put the whole thing in a loop. So I place the loop as the first thing in my block. I select everything that I've created, and then I drag it into the loop. Then again, we can download the instruction onto the robot. So now we've moved one step from the drunken sailor where we only had 2 control points for the machine. Now we have 5 control points for our machine. And the purpose of this initiative is to have a way of applying the math and science that our students have received in their classroom work. So this is not as, it doesn't behave as well as I expected it to be. I wish someone would be here to watch what is happening and give me feedback of why I'm getting that. Why I was getting that here. It would have been easier to do here. The robot is casting its own shadow, a black shadow on the path, and it is seeing that as a black, and it's trying to follow its own shadow. Do Because your program only dealt with what colors. So when he casts his shadow and he sees as a black, he will think it is a black part on the mat. So you can see this is not as zigzag as the first one we had. This is not as zigzag as the first one we had. The first one was quite a rigid movement. So if you try to divide by 10 instead of by 20, how many control points will you have? 20 control points. And that will give you a smoother movement. Are you following? Are we there? And if you divide it by 20, you have how many control points? By 5?
So I think the 5 will give you
5 will give you 20. It is 10 will give you 10 control points. Yes. So as many control points as you want to have, that is your choice to make. Are we there? Do you want to try? Or we should add one principle? So let me add one principle of navigating. So we've gone past the branching sailor. You can decide to have the number of control points you have, and you can decide to have them at different intervals. To say that one control point will be 30, that one other will be just 20 interval. That is yours to decide. So let's talk about this last one, then we can try our hands on something. So this is about proportional steering. This time we are going to what Jabema was saying. This time I'm driving. What I control is what? The steering. I'm not controlling the speed. I'm constantly moving at 50. What I have to do is to steer. It's like playing a video game. The car is always moving. You only have control over what? Over the steering. Or the game decides the speed and you have control over what? The steering. I follow it. So we could decide to move our car at a fixed speed and then have control of our steering. Now, our steering is going to be based on the road. If the road is curved, our steering must respond to that curve. Are we there? If the road is straight, our steering should not what? Should not respond to anything. It should just move. Good. So how can we do this? Back to the equations. And remember, the purpose is that we all become trainers. So the principle is what we are more focused on. Once you get the principle, as for the programming, it's not a big deal. So with proportional steering, using one light sensor, I have let's take this to be our steering axis. Telling how much steering you want to apply to your robot. I follow it. And then this to be your light sensor. So based on the value you are getting on your light sensor, there should be some steering that you apply. I follow it. With a single light sensor, what we have established is that if we are positioned halfway between the black and the white, it means we are on course. And we should be doing what? We should be going straight without any steering. I follow it. So what I can say is that for sure, I know that if my value is 50, steering should be what? 0. Do we get it? If the light sensor records 50, steering should be 0. So this point is definitely on my control line. Do we agree to that? The line or the equation that should be used to control the movement. Yeah, you are looking at autonomous cars. So you will not be there to control the steering at any curve. Which means you have to come up with an equation that the robot will use to calculate what steering is needed at what point. And that is the equation we want to build. Are we there? Now, one point that we know for sure is that if we are exactly half on the white, half on the black, when we record a light sensor value of 50, our steering should be what? 0. So this point is on that equation. What we need is another point to be able to draw the line, the control line. Are we following? So we will decide on that. And that will come one. The perfect one will come by practice. So I'll say that I can either that's my desired point. I want to always stay halfway. So whatever happens here is actually a deviation. What happens here is also going to be what? A deviation. So the amount of deviation should translate to the amount of what? Of control. Are we getting it? So if I have a deviation of, let's say, 10. If I have a deviation of 10, it means I'm recording what? 60. And if I have a deviation of minus 10, it means I'm recording what? 40. So for a deviation of 10, let us train this machine and say for a deviation of 10, you should apply, steering is ranging from 0 to positive 100 and 0 to negative 100, either to the right or what, turning to the left. I follow you. So for a deviation of 10, how much steering do I want to apply? So if we want to test our first training, so if it was machine learning, we will say we are training the car. So for the first train, what do we say? Okay, let us assume that for a deviation of 10, we apply steering of let's see that. For a deviation of 10, we apply steering of, let's say, 50. Let's assume that for a deviation of 10, we apply steering of 50. Then it means we have another point here. It means we have another point here. And once we have that point, we can draw a straight line. So let me draw my straight line. Which means for a deviation of minus 10, we have a steering of what? Minus 50. This is a straight line. I follow. Now I can get the gradient of this line, can't I? So m equals what? Change in y over what?
Change in x.
So what do I have? This point is what? 60, 50. And this point is 50, 0. Right? So change in y can be what? 50 minus 0 over what? Change in x. Minus what? 50. And that is 50 over 10, which is 5. Is that it? Gradient of 5 here. I think we can do it. My chosen steering appears to be a straight value. Is that my gradient? Or I've made a mistake?
That is that.
That's it?
Yes.
Okay. So my gradient is 5. Let's try our C. So our C becomes what? Minus m times what? Remember, y is equal to what? mx plus c. So c equals what? Y minus what? mx. If I pick this point, y is 0. So minus m, that is minus 5 times what? X at that point. That is 50. Are we there? So that becomes, is it 250? My figures are too bad. I chose the wrong steering. Let me choose it.
It's minus, right?
Let me choose a smaller steering. Okay, so a steering of 15. Steering of 15 or steering of one of those values. So I chose too much steering for an error of 10. If an error of 10 is translating to 15, and we should have thought about that. Actually, that's what we want our students to be doing. When the values are not right, no one should tell you the values are not right. Because when error of 10 translates to what? 50 steering, you have a maximum error of what? Up to where? If the maximum value for light is 100. So a maximum value of what? 50 for error. So if for error of 10, your steering is 50. For error of 50, your steering will be what? What steering would you need?
100.
Come again?
100.
100? 10 to 50. 10 to 50. Yeah, 5. So 250. But your maximum steering is 100. So you see the value we chose was quite bad. Good. So we said we are choosing what? Something smaller. Let me choose 15. So for an error of 10, I'm choosing a steering of about 15, which means this point becomes what? 60, 15, and this point becomes, stays the same. So we have 15, right, over 60 minus 150, that is still the same. Yeah. So we have 15 over 10, and that is what? 1.5. So our steering, our M is 1.5, and then our C becomes our C becomes 0 minus 1.5 times what? 50. Do we get it? So what does that result to? 50 times 1.5. 75, right? So our equation becomes y is equal to 1.5 times what? Light sensor axis. Our x-axis is always your control. So all the equations you've learned, we will try and do some small relation with calculus and integration, and you see that everything you have learned, they apply. Control systems is just maths. Pick the mathematics, come up with an equation that works for all situations, and then apply it in the control. So here we have y equals 1.5 times, always what the level. That's why those days, I remember my physics teacher, when you draw a graph without leveling the axis, they mark the whole way wrong. Because you have lost the control. The values there don't make any sense any longer. So here we say 1.5 times light sensor minus what? 75. This equation gives you what? The y-axis is what? Steering. I follow. It means this equation can control your car. Your steering should always be equal to 1.5 times the light sensor reading minus 75. So we want to build this equation and feed it to the steering when we are moving at a constant speed. Are we there? Are we there? Good. So let's try that. So let's try that together. So this time we say the control for our autonomous car is not directly from the light sensor reading as we're doing, but we'll say that whatever the light sensor records, we want to multiply it by what? By 1.5. Are we there? We want to multiply by 1.5, so we say we need a math block to do what? Multiplication. So we say the light sensor reading so 1.5 goes here, and then we do what? We subtract. So I pick a math block. This time to do what? Subtraction. What am I subtracting? I'm subtracting 75 from the result. So we say the result that comes out of this, let us subtract what? 75 from it. And then the result should do what? I have a move steering block here. Now look at the move steering block, how it behaves. It says I have two motors, one on A, and I have one on what? On D. That's for a robot. Now it should be moving at a constant speed. Let me turn it on. So here I'm programming the robot to be on at a constant speed of, let's say, 50. Or at a constant speed of, I like to drive at slow speeds. So at a constant speed of 30, the only control I have is what? Steering. And my steering, I have worked it out. So I only feed the output of this equation to what? To steering. I follow you. And say, be moving. Your steering will come from your light sensor. As long as your light sensor is taking the signal, he will tell you how to steer. Are we there? So let us put this whole thing in a loop. We put this in a loop, and then we download to our robot. So not now, let's download. So now I can see both are turning, but one of them is turning what? While the other is turning back. He's trying to get some control. Let me see how it behaves. iPhone. So this time it is driving at a constant speed and it is steering itself using the equation we came up with. If I want to optimize it, I have to go back to my equation and say, okay, I think the steering is maybe too sharp or too slow. So let me change. What do I change? I select a value for. I select the value for. So that is proportional steering. You are steering based on the proportion of light coming through the light sensor. Are we there? So do you want to just try our hands on one or two of them? Let's try our hands on one or two of them. One person should come in. Adam, face yours. You come in. Try it in. I like worrying you. Yes, I'm worrying you because you have a task ahead. No, but let's those you have the software on your machines. Okay. So
You want to hear it?
I want you to explain. While they work. So while they work, you will show me the principle. How constant steering works.
It will pass before you go down.
You people, you have just 10 minutes. Okay, you'll be the next to do this. I'm the listener to you. They are trying this. So you can.
What we did is when we start.
The one is
so you can pick your values. You can go and pick your values.
So how you pick that values?
using these values. You take the listing do. So unless you go there and take the value.
People, we don't have to.
I said 10 minutes.
You take readings, you do your calibration. You take readings, you do your calibration, then you program.
They go to you.
Any of the techniques
That's a no more.
No more.
I don't see
before
that.
we move on.
Mike,
I said take readings. There were two of you who went to join. So you take them to the board.
Let's go.
No, it's like nice.
Is it after
It's like
over to you.
I know it is. 5 minutes. No, to know. As I say, you go the port, you go the program, you go the port. But now I give my phone.